Okay, so I want to reiterate when you might see an exponential function. So a general sketch of an exponential function would be something like this. And the formula from high school, I believe you guys are probably familiar with the PERT formula. So A equals PE to the RT. And oftentimes you were talking about interest that was compounded continuously, where P was your principal, A your accumulation, R is your growth or decay rate, and then T is the time that it took in order to get from P to A. The mathy way of writing this is that P of T, your population after some time P, is equal P sub 0, your initial population, E to the K T, right? Pretty much the same thing, where K is still R, it's your growth rate or decay, and then T is the time that it takes to get from your initial population to your final population. Okay, so let me write this down. This is going to be your final population. This one will be your initial population, what you started with. E, as you remember, this is approximately 2.718. Your K and your R, these are either your growth or your decay rate. Okay, what you have to remember about that is always in decimal. So what do I mean by in decimal? It means that if you are using 3% growth, then it should be 0.03. If you're using 10% growth, then you should be putting in 0.10. So please keep that in mind. And then the last thing that we need is the T. Right? So this is the time it takes to get from initial to your final population. And that's it. All right. So the question is, when would you see an exponential function occur, either in real life, in the business world? You actually see these occur often. Looking back at the graph, you'll notice exponential growth. It doesn't have a steady incline or decline, if you will, that you're going over a certain amount and then going up and going over and then going up and going over and going up. That's what linear is. Certainly not quadratic. You don't see your function as coming down and then coming back up. You only see an increase. This is exponential growth, exponential decay. Let me show you what that'll look like really quickly before I get back to what I was talking about. So to be clear, exponential growth is going to start at a point and it'll shoot up over time. Whereas exponential decay is the opposite. You'll start at a particular value and it will drop rapidly. Right? So the difference between these two is that this one is going to be P of T equals P sub 0 e to the negative K, right? Or you could just say K is negative T, right? You can make note of that. Okay, whereas here, K is going to be a positive value. All right, so you're looking at either rapid growth or rapid decay. So when would you see rapid growth? If you take into consideration your grandparents' generation is called the baby boomers, and the reason is that they represent a very large growth in population. Their parents went off to war. Their fathers primarily went off to war, and when they came back, there was a resulted large increase in the general population. So you had your population that may have been steady, and then all of a sudden all these babies were had, and the population grew exponentially. What else might you see? The example I like to use is of amoebas. So if you look at them as a cell, so say you have one cell in a dish, and that cell splits. Now all of a sudden you have two, and that cell, those two cells split. Now all of a sudden you have four. Those four split, you have 8. Those 8 split, you have 16. Those 16 split, you have 32. So you'll notice very rapid growth, right? So I stopped at 32, but you could get to 64 and 128 and still see this rapid growth occur. Exponential decay, this happens in the business world. An example of this was when the stock market crashed. I had a friend who bought stock in, I believe was Panera Bread, and it was doing really well, and then everything fell apart and the value of the stock declined rapidly, right? Another nightmare that occurs for homeowners like myself is that you purchase a house and then the value of the house has dropped and it becomes a buyer's market instead of a seller's market. I had a friend who purchased a house that was initially valued at $500,000. So I'm going to put this number in just for a minute. $500,000, and it only was like 6 years after the woman had purchased the house that my friend bought her house, and he purchased the house at $250,000. So notice a rapid decline in the value of the house, right? So in the business world, you often see exponential growth and exponential decay. Another example of the business world is continuously compounded interest. So if you remember from when you were in Math 120, you had interest that was compounded annually. You had interest that was compounded twice a year, compounded quarterly, compounded daily even. Okay, so if you have interest that is compounded continuously, this means your interest is compounded. A lot of students like to think of it as every second. So if your interest was compounded every second, then it would grow. You would see this exponential growth. If you're every moment that you were breathing, if your interest was being compounded, then you're going to see a drastic increase in the amount that you would have in your bank. So that's why when you see this phrase that your interest is compounded continuously, you're going to use what you guys like to call the PERT formula, right? Interest is compounded continuously. So that means your money is growing incredibly quickly. All right, so what I like to do is take a look at some of the problems that you guys have in your notes. And this is on day 8 of your notes on the exponential growth. And I'll just start off with this first one. I want to show you what that says so that you can know where I am.